Assalamu alaikum. Hello everyone. This is Mehdi Hassan Chaudhary. My ID is 12008004. Today I am going to talk about a very fascinating part of ML security titled Adversarial Attacks on Computer Vision. So let's get started. So nowadays AI is gradually spreading. In near future it will be in every aspect of our life. From autonomous driving to medical services and security surveillance systems and so on. But the question is, can we trust them entirely? Or in other words, will they always, or can we make them fool? Or can we just make their judgment fuzzy? The answer is yes. Welcome to the world of adversarial attacks on computer vision. So imagine this. A self-driving car approaches a stop sign, but instead of stopping, it speeds through the intersection. So what's wrong? What's the culprit here? A tiny sticker, invisible to you and me, but devastating to the AI's eye. So what exactly are adversarial attacks? They are carefully engineered changes to images, changes so small that human eyes can't detect them. We are talking about modifications to just a few pixels or adding what looks like random noise. The fascinating part is that while these images look completely normal to us, these two images looks completely normal to us, they can completely fool the AI systems. To a human, it's still a stop sign, but to the AI, it might interpret it as a speed limiter. So these aren't just theoretical concerns. Adversarial attacks are happening everywhere in real world. As we see, a small pieces of stickers placed on stop signs can make autonomous vehicles misread them as speed limit sign. Imagine the consequences. It will not stop. Again, special glasses and clothing patterns have been designed to make people invisible to the facial recognition system, bypassing the security surveillances. Not only that, even object detection systems can be fooled. Just a few patches added on your clothes can bypass surveillance and detection systems. As we see here, it can detect a person, but just for a small amount of patches, it can't detect any person. Strange, right? So now let's talk about the science behind this. How do they work? It's actually a bit unsettling. First, an attacker starts with an original image that the AI correctly identifies. Then they use the model's own mathematics against it by calculating the gradients or essentially understanding how the model makes decisions. They can determine exactly which pixels to modify or alter to force the AI making wrong decisions. And they add the noise or alter the pixel values, and the result, an image, looks identical to human eyes. These two are panda, right? As we can see, but causes catastrophic errors in the AI. It just misinterpret this panda image as a given with 93% confidence. So why does it matter? Why should we talk about adversarial attacks? Here. Because AI is everywhere, making critical decisions. Autonomous vehicles needs to correctly identify road signs and pedestrians. Life depends on it. And surveillance systems should reliably identify threats or at least not be easily bypassed. And medical imaging AI helps diagnose diseases, and mistakes can have serious consequences, right? And in cybersecurity, malware must be detected properly, but it's not all doom and gloom. Understanding these vulnerabilities drive us to build better, more robust AI systems. Researchers are developing defenses such as adversarial training that teaches model to recognize attacks, pre-processing techniques to clean inputs or noises, and detection systems to identify when something is wrong. Or sometimes ensemble methods can be used to tackle adversarial attacks. So the battle between adversarial attacks and defense is ongoing, an arms race between those finding vulnerabilities and those building protections. What adversarial attacks ultimately reveal is profound. AI systems see and understand the world fundamentally different than we humans do. As we deploy AI in more critical applications, understanding these differences isn't just academic, it's essential for building trustworthy, safe AI system. The race continues, and the stakes have never been higher. That's all. That's all from my presentation. Thank you, everyone.